Sun in only 6 months instead of 12. I mean, it's really easy to do. All you have to do is decrease the orbital radius from Earth to Sun. Now, is that true? Sure. But is it relevant to physical reality? No. And a key thing in science is that your predictive models have to fit observable reality. We can model anything, but if it doesn't match or predict observations, it's not a scientific model.
Right, but because the theory of evolution takes a long period of time to supposedly happen, many only accept uniformitarian ideas.
That's not why, and let me add some context here, in case you're unfamiliar with the history of creationism. The theory of plate tectonics was formalized in the 1970s, and it provided a mechanism to explain what had long been known, that the continents had rearranged over geological time, and this drove uplift and volcanism, earthquakes, and so forth. It further explained the origin of continental and oceanic crust. Now, since then, the theory has been so well corroborated that even young Earth creationists have decided, okay, we have to accept plate tectonics. The evidence is overwhelming, but it doesn't fit our timeline, so what do we do? Well, Dr. Baumgartner made a simulation in which he arbitrarily raised the temperature of the asthenosphere by a few hundred degrees. So it's kind of like heating solid wax until it actually becomes a lubricant and really easy to deform. And then he gave the tectonic plates a push, and the heat generated by that movement kept the boundary hot and relatively frictionless, so that plate motion was at least orders of magnitude faster than today. In his simulation, however, enough heat is generated to boil off much of the oceans and melt the crust. The only way to cool off the newly forming lithosphere, so that matches modern observations, I mean, there is an ocean floor. The only way to cool that off, though, is to give it a steam bath, and yes, he really did propose this, by circulating more than 1,000 meters of ocean evenly through tens of kilometers of semi-molten rock, which is then blown out to space by supersonic jets at plate boundaries. And let's not forget, catastrophic plate tectonics begins with a configuration that looks like Pangaea some 250 million years ago. But at the beginning of the Paleozoic, the continents were spread apart after the breakup of a much older Precambrian supercontinent called Rodinia. And before that, spread apart. And before that, another supercontinent. So even if the folks at the Creation Museum could explain how we got from Pangaea to today, or even from Rodinia to today within a few thousand years, which they can't, but if they could, they're not even close to explaining our tectonic history. So are you beginning to see why nobody takes this seriously? But hey, for the sake of discussion, let's try. As I said, it's not a question of how fast things could happen, but how fast did they, given the evidence. And there are thousands of lines of evidence from which we could constrain plate motions in Earth history, and by which we can rule out this asinine conjecture of catastrophic plate tectonics. So from radiometric dating of the ocean floor to see how long it took for that ocean floor to be generated, you can look at lavas on either side of a rift zone and compare the dates of those lavas with the modern observed rates of rifting according to high precision GPS, and they match extremely well. We can analyze the chemical alteration of the seafloor that happens around hydrothermal vents near the mid-ocean ridges. We could model the heat and buoyancy loss of oceanic crust as it moves slowly away from that ridge, all the way to correlating the height of ocean ridges with past glacial cycles. And yes, the thickness of ocean floor has varied along with sea level, which is driven by how much glacial ice is on land. Interestingly, the more water in the ocean, the heavier the weight that's pushing down on the seafloor and the thinner the oceanic crust will be. Not by a lot, but it's enough that we can track these cycles on the ocean floor and match them with the terrestrial climate records. So we can also look at subduction zones, how volcanic ranges are formed in response to subducting plates, which would not be the case if subduction were catastrophically rapid. We can track the latitude of continents through time by using the alignment of magnetic minerals in the rock. And these paleolatitudes just happen to correlate to the inferred climate history. For example, Cambrian limestones in Iowa must have formed on tropical shorelines, and that part of the continent just happened to be at like 10 degrees latitude. That's not a coincidence. So no, we don't suppose that plate tectonics is a slow process just because of an a priori commitment to uniformitarianism, which, by the way, is an already outdated concept.
Uniform a who?
Oh, it defines it right here. Geologists make inferences based on the principle of uniformitarianism. This principle states that the same processes that operate today operated in the past.
Not really. I wouldn't worry so much about the precise definition here because uniformitarianism stems from a time when geology was far more speculative and ruled by various schools of thought. Modern geology, by comparison, is so flooded with data that the guiding principle is basically, hey, if you think it happened really slow, like this, provide your evidence.
How do you hit this? Double barrel shotgun or something? Ah, okay.
Ja, siehst die Import nicht.
seconds, JJ. Try to get through as quick as he can.
Земляк, я тебя хотел.
Need to fix them fucking scabs. Oh, I need an angle on me. Come on, Charles.